Aim. To measure the thickness of the given glass plate and diameter of the given wire. Apparatus: screw gauge, glass plate and metal wire. Screw gauge, most commonly known as the micrometer screw gauge, is an instrument used widely for precise measurement of small objects such as wire. The word screw gauge is used because this device is most commonly used to measure the diameters of the wire, which in turn are governed by standard numbers, which are called as standard wire gauge. The word micrometer represents the principle on which the device works, which is called the principle of micrometer screw. Principle of micrometer screw. When an accurately cut single-threaded screw is placed inside a closely fitted nut and rotated, in addition to the circular motion, there is also linear motion of the screw along its axis. This distance moved by the screw in one complete rotation of the screw is equal to the distance between its two consecutive threads. This distance is called the pitch and is always constant. In this way, the small distances moved by the screw, which are the linear distances, are amplified into larger distances, which is the rotation of the screw. These rotations can be easily measured than the linear distances moved by the screw. Thus, the screw gauge is constructed in such a way that it incorporates the principle of micrometer screw. In addition to the screw and the nut, a U-shaped frame is attached at one end of the nut. This nut, also called the sleeve, has readings on it. These readings measure the linear distance moved by the screw. This scale is called the linear scale or the pitch scale. The other end of the U-shaped frame has a metal projection called the stud. When the screw is moved forward, the stud and the screw together hold the object firmly. The screw is attached to a milled head with a sloping edge which rotates over the sleeve. The sloping edge has a scale which is called as a circular or a head scale. The pitch of the screw gauge is the linear distance moved by the screw divided by one rotation of the screw. To find out the pitch, the circular scale is rotated to bring the zero mark on the reference line. The linear scale or the pitch scale reading is noted down. We count the number of divisions on the linear scale completely uncovered by the cap. Here it is 2.0 millimeters. Now we rotate the screw 5 times. When the zero mark of the circular scale again arrives at the reference line, one rotation is said to be completed. We again note down the linear scale readings after 5 rotations. It is 7 millimeters. We get the linear distance moved as 7.0 minus 2.0, which is 5 millimeters. Thus, pitch can be calculated as 5 millimeters divided by 5, which is 1 millimeter. The pitch of the screw is 1 millimeter or 0.1 centimeter. Therefore, the distance moved by the screw in one complete rotation of the circular cap is 1 millimeter. Now, the circular cap is divided into 100 divisions. Then, if the cap is moved through one division, then the distance moved is 1 by 100th of the pitch, which is the least count of the screw gauge. Pitch divided by number of divisions on the circular scale is equal to 1 divided by 100 mm. which is 0.01 millimeter or 0.001 centimeter, which is 10 to the power of minus 5 meters, which is 10 into 10 power of minus 6, that is equal to 10 into micrometer. In addition, as the least count of the screw gauge is of the order of micrometer, it is called as the micrometer screw gauge. Now, after determining the least count, pitch and the zero error of the screw gauge, we are now ready to find out the length of any object. Let us say, to find out the diameter of a wire, we place the wire between the fixed stud and the screw by slowly moving the screw with the help of the ratchet until the wire is gently held. The diameter of the wire is nothing but the distance the screw moved from position A to position B. This distance is equal to length of the portion X plus length of the portion Y. As it can be clearly observed, portion X is 1 millimeter as the scale is graduated in millimeters. That is, the screw has completed one rotation. Portion Y is less than 1 millimeter because the screw did not complete a full rotation but crossed 31 divisions on the head scale. Therefore, mathematically, for one complete rotation of the screw, the reading is 1 millimeter. That is, 100 divisions is equal to 1 millimeter. Therefore, 31 divisions is equal to 31 into 1 millimeter divided by 100. Therefore, portion Y is equal to 0.31 millimeters. Total length is equal to portion X plus portion Y, which is 1 mm plus 0.31 mm, which is 1.31 mm or 0.131 centimeters. Now, portion X is equal to linear scale reading. Portion Y, N, is equal to 31 into 1 mm divided by 100. 31 is the number of divisions of the circular scale crossed by the reference line of the linear scale. 1 mm divided by 100 is the least count of the screw gauge. Therefore, total reading can be represented as linear scale reading plus N into least count.
The linear scale reading is 0 millimeters. Now, look for the circular scale division which cross the reference line on the linear scale. Here, the circular scale division is 55. Now, we multiply this division with the least count of the screw gauge to get the circular scale reading. It is 55 into 0.001 centimeters, which is equal to 0.055 centimeters. Total reading is equal to linear scale reading plus circular scale reading, which is equal to 0 plus 0.055 centimeters. Therefore, the total reading is equal to 0.055 centimeters. Now, keeping the wire in the same position, rotate it by 90 degrees for measuring the diameter in the perpendicular direction. Now, repeat the same procedure at 3 to 5 different positions distributed equally throughout the wire. At each position, we take perpendicular direction readings as well. Note down all the readings in the observation table. Scale division which is clearly visible and uncovered by the edge of the cap. Here it is 10 millimeters. So, the linear scale reading is 10 millimeters. Now, look out for the circular scale division which cross the reference line on the linear scale. Here it is 88. So, the circular scale division is 88. Now, repeat the same procedure at 5 different positions distributed equally throughout the given glass slab. After every measurement, we note down the values in the observation table.
Zero error is equal to nil. Zero correction is equal to nil. Length of one division on the pitch scale is equal to 1 millimeter. Distance moved by the head for 5 rotations is equal to 5 mm. Pitch of the screw is equal to distance moved by number of rotations, which is 5 mm divided by 5, which is 1 millimeter. Number of divisions on the head scale is equal to 100. Least count is equal to pitch of the screw divided by number of head scale divisions, which is 1 millimeter divided by 100, which is 0.01 millimeter or 0.001 centimeters. For a pitch scale readings 0 mm, head scale coincidence observed is 55, corrected is 55. Fraction is equal to 0.55 millimeters. Therefore, total reading is equal to 0.55 millimeters. Similarly, the diameter of the wire at different positions of the wire are: mean diameter of the wire D is equal to 0.545 millimeters. Mean radius of the wire R is equal to D divided by 2, which is 0.2725 millimeters. For a pitch scale reading of 10 millimeters, head scale coincidence observed is 88, corrected is 88. Fraction is equal to 0.88 millimeters. Total reading A plus B is equal to 10.88 millimeters. Readings for thickness at different points of the glass plate are: mean thickness of the glass plate T is equal to 10.875 millimeters. Precautions. Screw must be rotated by holding only milled head provided with safety device. Hold the wire gently between the studs. Always move the screw with the help of the ratchet. All the readings should be taken in millimeters or centimeters. Pitch scale reading and head scale reading should be noted without any parallax error.
दोस्तों, आपको वीडियो कैसी लगी हमें कमेंट करके बताइए। यदि अच्छी लगी हो तो लाइक कीजिए, चैनल को सब्सक्राइब कीजिए और दोस्तों के साथ इस वीडियो को शेयर कर दीजिए।